Okay, here we are in the lab again, and this is episode number 14 of Build Your Own Main Brain Microcontroller project. And so, this is the big one. We have most all of the minor stuff covered, you know, like the I2C. We have all the basics. Now, we got to start worrying about components that we're going to interface to. So, one of the biggest, probably the biggest thing to interface to is the display, because it has three things. It has the backlight, it has the touch, and it has the display controller itself. So that's what we're going to do today. Is we're going to start. It's going to be a multi-part series because the display's big. So, but we got the basics down. We got the parallel interface down. We got the I2C down, and we got the buzzer and stuff like that taken care of. So now we're ready for something bigger. So we're going to do the display. And so the first thing we got to do is to determine what kind of display we have. So this is a display, and I have it stuck to some fiberglass material so I can mount it on mainbrain. I don't have one that isn't mounted yet, but this is the ribbon cable, actually the flexible circuit that it connects to. This is the interface, so the big wide one is the parallel interface and all that for the display controller, and then this one here is the I2C interface for the touch, and that is actually the microcontroller, the touch controller right there. And the signals go up into the touch controller, goes over the top of the display. And you can order the display without touch, and you can use order it with resistive touch and capacitive touch. All right. So that is the physical display itself. So when you power mainbrain up, you get this displayed on the screen, just like, you know, the logo. You got to have something, right? So in order to get to this point, a lot of things have to happen. A lot. So that's what we're going to cover. And so the very first thing that we have to do is to discuss what kind of display we even have. Okay, so here is the display data sheet. And so it's a TFT display module. That's what they call it. This is the part number. I get it from here, Crystal Fonts America. I don't know if they manufacture it or if they just get it like from China or whatever, but this is where I get it. They have a large selection of all kinds of different displays and different sizes. So I'll come down here. So it's a 3.5-inch diagonal, full color TFT graphic display module with a capacitive touch screen and a white LED backlight. So that's three things. That's three separate sections that we have to learn about. So it only requires 3.3 volts to power the whole thing on the display. So you don't have to worry about any kind of additional voltages or anything, just the 3.3 volts that the rest of mainbrain runs on. All right. So it has a built-in controller, graphics controller, and this is the controller. All right. And it's made by Ilitech. I guess that's how you say it. And so it's an ILI 9488. So we're going to write our driver code based on this. All right. So we have to come down here and we have to get this data sheet to start programming the controller. All right. So then they have a link here. And we also have a controller for the touch operation, the touch screen. and that's the FT5436. But you notice they don't have a link to it. This is definitely Chinese made because there is very little data sheets available. You have to dig. And in fact, most of the code that I have, I used some GitHub code as a reference, and that's the main source. It's hard to find anything about it. All right. So features. It's a 320 by 480 dot matrix. All right. But you can rotate the screen, so it can be a 320 by 480 or a 480 by 320. And I use it as a 480 by 320, kind of like the cinematography type display that you see like video. Kind of, it's short height and wide width, like a 9:16, but and it's not a 9:16, but in that form. Or you can stand it up, so that's a 320 by 480. You can do that too, and that's just some simple stuff to do. So we'll get into that definitely later. All right, viewing direction 6 o'clock. That's just some technical stuff about the way you can see the display and stuff like that. And so the interface could be set to be parallel 8-bit, 9-bit, 16-bit, or 18-bit. And mainbrain's set for 16-bit, but it easily can do 18-bit if you just do a modification. Or you can use SPI interface, 3 or 4 wire SPI. And then they have this dot clock RGB with SPI. We won't really get into that, but that is an option. So yeah, like I said, the touch panel has this microcontroller built in. It only uses I2C, and we went over I2C just recently. And so this is the address, 7-bit address, or you can use this address to write and this address to read with an 8-bit. All right, and we'll get into that too. It provides up to 5 touch points, which is kind of a lot. I mean, how many touch points do you need at one time, right? But it can support 5. In my code so far, I only detect the touch points. I don't do anything other than a single touch point. So then here's the mechanical stuff. We kind of need to know the dimensions for our project. So here's the interface right here. So it's a fairly simple interface, but since it has all the different interface options, you have to set the IMO, IM1, and IM2. You have to set it to your interface. So mainbrain is hardwired for 16-bit, where IM1 is high and the other 2 are low. But if you took and pulled this low, then you would have an 18-bit interface. You could change these on mainbrain by cutting a trace and hardwiring it. Or you could just design it in your design to be able to switch it. All right. But mainbrain is wired for 16-bit. All right. Because the parallel interface has data bit 0 through 15. All right. And anything above that, it has to get bit banged from a port pin. And mainbrain does have port pins set up for 18-bit, but it's hardwired here for 16. All right. And then we have a reset. So when this signal is low, it resets the display. So this gets tied in with the master reset on mainbrain. And then this we don't worry about because that's part of the RGB DPI mode. Same with P clock. Data enable, same thing. Here's our data bus right here. All right. But we use DB0 through DB15. If not used, tie it low. All right. And we'll look in at main brain schematic here in a minute. I'll show you how it's wired. All right. So then these are not important parallel read signal. So it's just like any other I/O device that has a read and it has a write. So we wire that to the system bus. Now this DC, we bit bang this. This is how you select whether it's a command or if it's data. All right. So if it's low, it's a command, and if it's high, it's data. All right. So that means when you have, if you want to send data to it, then you pull this pin high, and then you write to the data bus, and that signals that it's data. And if you want to send it a command, the same thing, you just pull it low, write to the data bus. All right. And this is the chip select, just like any memory or I/O device on the system bus. It has to get selected first, and when it's not selected, then its data bits are in the high impedance state so that it doesn't have a bus contention. Now this is the backlight anode, and this is the backlight cathodes. So they have 6 of them. All right, and then our ground. All right, so that's the interface. All right. Now the touch, this is the touch screen interface. We went over this a little bit before. We'll go over it again, but it's the I2C 2-wire I2C interface, and it has an interrupt that goes to the microcontroller, and in our case, mainbrain's microcontroller. And when any touch occurs, it doesn't matter where or anything on the screen, it sends an interrupt to the microcontroller, so then the microcontroller can read the data and determine what happened and what to do. And this is a reset, active low, so it's tied into, I believe, we'll have to check the schematic. I think I tied this into the system reset, but I may not have. I might have this go into a port pin so we can reset it. I think I did. So you can reset it during operation. And so this is the voltage characteristics. I can run to 4.6 volts. This is the logic supply. It's pretty much has to run on 3.3. Although typical is 1.8, which I think that's internal though. I think that's internal. But in any case, we use 3.3 volts for main brain. All right, so here's some touch characteristics, backlight characteristics. Everything is 3.3 volts. And here's some technical data about the optics. This is how the backlight works. So you have your anode and your 6 cathodes. And these go around different points. They're behind the screen at different points. So if you only lit up one, you wouldn't have a full, smooth, lighted display. There'd be one section brighter than the other. So it has 6 different points behind the display that it lights up. So some people, if you want to get picky and you want a really smooth, nice backlight, then you use a constant current chip when you power the backlight so that each one gets precise amounts of current. But I just power it with a PWM, and then you can control all of them equally. Nothing, I don't get too fancy with that, and it seems to work really well. All right, so then it has some precautions. Don't exceed the maximum ratings. Don't get it too hot, this and that. Yeah, okay, so that's pretty much it for the display data sheet. So now let's just take a look at how mainbrain is wired up, and then we'll continue onward. Okay, first with the Windows updates always like resetting stuff after it updates, my microphone got like reduced volume. So I mean, my maximum setting I can do right now is like low. So there's a little bit of low. You have to turn up the volume, but then after that it should be okay. But anyway, that is the data sheet, the general data sheet for the display. But it's not the data sheet for the controller. So the controller is what we're actually going to program. And there's two controllers. There's the display controller and the touch controller. So we're going to get into all of that soon. So next, we're going to take a look at the schematic, the way MainBrain has it wired up, to give you an idea of the physical connection to the display. All right, here we are at the data sheet, and this is the interface for the display. And so there's a lot of just like redundant pins. Here's your IMO, IM1, and IM2 that set the interface type. So they are hardwired. So if you wanted to change that on MainBrain, you would have to cut a trace and move it to either 0B or VDD, whichever you required. Or you can just design it in so that you can change it with some jumpers or even with the microcontroller or however. And so it's just like we talked about, the reset right here goes to the system reset for the microcontroller. And so the data sheet wants you to pull certain ones high and certain ones low that you don't use. So VSync and HSync are pulled high. P clock is pulled low. The DE active low. So then D16 and 17 are the upper bits for 18-bit interface. So as you can see, I have them go into port pins. So they should be kept low. According to the data sheet, since they're not used, they should be kept low. And we're set hardwired for 16-bit. So you can't use those two without changing this. All right, so MainBrain is pretty much 16 bits. And color-wise, that's pretty good still. But if you want even more color, then you can work these two in by enabling the 18-bit interface up here. All right, and then so it's just 16 bits interfaces to the parallel port, like we discussed. We covered the parallel port previously, and so then everything else is either left open or tied. Now, this is the backlight here, and all it is I tie all the cathodes to 0, to ground, and to BSS. And so then the anode is driven by a MOSFET, and the MOSFET is driven by a port pin RD4. All right. And that is a PWM, comes out and controls the brightness with the PWM signal. So the frequency is pretty much set, and so the duty cycle regulates the brightness of the display. All right, pretty simple, pretty simple. And so that's it. And then we have our touch screen interface over here. We touched on that previously on the I2C interface. And so we have some voltages and a common and two commons, 2 voltages and 2 commons. The 2-wire I2C interface. We have the interrupt that we talked about, where when you touch the screen, it sends an interrupt to MainBrain, to RDO, which is actually interrupt 0. All right. And then we use an interrupt within MainBrain to handle it, the function. And then a reset. And so it is not tied to the system reset. it's tied to a port pin RB13, and that way you can reset the touch controller at any time during your program. All right, anytime during runtime, as you would say. And so then to be within specification of the I2C, we have 2 pull-ups like we discussed in the I2C video. And so that is the 3 so-called interfaces for the display. The display interface, the touch interface, and the backlight interface. All right. 3 sections that we have to program. We have to write code, driver code for each of those 3 sections. Okay, so I should mention this probably more, but the support website is just antimatter.me. If you go type that into your browser, you will come here, and this is where all the support files are. Probably not as many as there should be, but I'm working on it. So the first thing we want to check out is our data sheets, okay? So this is a list of the data sheets that are available. And so we got different ones for different things. Here's our data sheet for our display. And then here's one for the FT for the touch screen. Then we got an I2C. Then this one is what we're going to go to next. This is the controller for the display. Okay, this is the data sheet for the display. And so the way it is, you have physically you have the display, the LCD screen. And it has all these connections around the perimeter of it inside. And so the controller, internal controller, this ILI 9488, interfaces with each of those wires and controls every single pixel. And each pixel is a specific location in this graphics RAM. All right, and you can have up to 16.7 million colors. That's with the full 18-bit interface. And we're using 16, so we're going to be lower. We're not going to have 16.7 million. All right. But you can get 16 million colors. All right, so the table of contents, this is a pretty big data sheet. It has all kinds of different stuff, and we're going to go through most of it. The main thing is, once we have this set up, then we're only going to be doing 16-bit. All right, so that is called an RGB 656. And so this is a block diagram. And so you have the different interfaces and stuff, and then this is how it works internally. And this is the graphics processor, and it interfaces. See, it has like 960 pins, there, and a bunch here because it's like, a matrix. But that's all internal. We're just talking to this interface here, right? Just writing through the data bus, just like any kind of other device, memory or whatever, right? So this is the operation mode of the microcontroller inside, see? And it can do 24-bit, but we don't have it physically on the interface. We do not have this many bits. We only go to 18 bits. But the microcontroller inside the display, this ILI 9488 device, can do 24-bit, right? But our part number for the display, it can only do 18-bit maximum. All right. And so then they have different termination, different naming for different things than the data sheet for the display. All right, but this is what we're going to have to write our code to. It's this ILI 9488. So we have to go through this data sheet and try to understand all the different things about it. But not every part of the data sheet is specific to our application. It covers all the different interfaces and stuff like that, which changes the way the data format is and everything. So you only have to worry about your specific interface, whichever one you choose. And like I said, we don't have the ability to do the 24-bit. If you can order a display that does have 24-bit, but the interface would probably change a little bit. Obviously, it would have more data pins. All right. So, see, they call it the reset X for the reset signal. And they just add like an X to it because it's a different company. It's Ilitech. It's the one that makes the processor, right? So some company, probably in China, gets this processor and interfaces it with the display and puts it in the processor on there and ribbon cable and adds the touch screen and then sells it as one unit. And that's what we're buying. But there's different processors, different configurations for the display, different sizes, different resolutions, different interfaces, and a whole bunch of different options for each different kind of display. And so you have to keep that in mind. But that's the way they build them. And they might choose a different processor for a different display to give different options and stuff. But right now, the one we're focused on is this ILI 9488. All right. And so they have a lot of pins and stuff on the microcontroller that we don't even see because it's internal to the module. But it's what we are concerned about. See, this is how it interfaces, and it has a lot of pins in there. And that's why they have that microcontroller built in, because we would not want to design our project for this kind of interface. That would be very energetic and beyond the scope that I would want to do, put it that way. But it might be an interesting project sometime to actually just take a bare display and try to program a microcontroller to run it, because there's a lot of technical stuff about the way it has square waves that overlap, and that lights up a pixel from the X and the Y axis, and it gets kind of technical. But we don't care anything about that in this application. And it tells, see, now here's the different protocols. We have to find our protocol here, which is, so this is the 16-bit parallel MCU interface. All right. And that's what we are using on MainBrain right now. It's like the old 8080 system for you old guys out there. So we have the chip select, we have the data command control line, we have the write, we have the read, and we have the data bus. All right. And that's pretty much it. Just a standard microcontroller, microprocessor interface. All right. Available display data formats are 65,000 colors for 565. So 5 and 6 is 11 and 5 is 16, right? So 3 6s is 18. So if you have the 18-bit, you have 262,000 colors. 16-bit, you have 65,000 colors, which is still quite a bit. It depends on if you want to do some kind of heavy duty like graphics or something. All right. So the format is for the 565, which is what we'll be talking about exclusively. So you select the device. You select command, right? Command is active low, data is high, and then you set up your data, and then this is when you write to it, and then you have to write each color, red, green, blue. You have to write all of this format, and you have to. This is one 16-bit word, and this is the second one. This is the third one, right? So this is the 16-bit. You're mapping it to the 18-bit, basically. There's converters online. We're going to use that too. But that's the basic idea of how to write a pixel. And notice that they're not in sequence, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I guess it is. Yes, I was looking at it wrong. So yeah, so DB0, DB16, all right? So that's the format of writing a single pixel. And that's just your color setup for the pixel. All right, you still have to tell it where to write to. Okay, so that's an overview of just some stuff about the display. Don't worry, don't stress on it. It's just an overview, and we're going to cover everything in detail, minute detail. So that was just a taste. We're just trying to get on the same page and see what's going on and what we have to do. So that is a quick overview of what it takes to program the display to get started. So we're not going to worry about the touch for a while. That'll be down the line, probably the last thing, because you don't have to have the touch programmed or functioning at all to show something on the screen. So, and we just want to put a pixel on the screen. That's our goal first. We just want to get the thing powered up, initialize it, and write some data to make a pixel show up on the screen anywhere. But we'll do it like in pixel number 1 or whatever, right? Because when you write a pixel, you have to tell it where to write it. So it's where it shows. It's not a hard thing to do. So we got to get the backlight powered up first. So you can either just hardwire that to 3.3 volts to where all the cathodes are grounded, and you just power the anode from 3.3 volts. No, and that'll give your backlight. And then because without your backlight, you can't see anything on an LCD screen. All right, even if you write data to it. All right, so you can have data on the screen and turn the backlight off, and it goes black, and it's the way it is, right? Looks dead. So we got to get we'll cover the backlight next, and we've already done PWM stuff, so that's just going to be a real quick breeze, and then we'll dive into initializing the display. All right, but that's it for this video because we are already at 30 minutes. So that's an overview. In the next video, we're going to do the backlight and dive into the actual configuration of the display.